This video will be an introduction video to Tribology. It's a new chapter that talks about the interface between different bodies. Alright, and this interface itself, if you were to zoom into a micro level, alright, there'll be a certain surface roughness in there. So if you think about it, different surfaces touch each other. So there will be a certain friction in between them that will cause certain stresses or unnecessary stuff that are occurring. So therefore, this is why we study tribology in this series. So the purpose of this particular video right now is to discuss on the introduction this part, alright, and that what is the relationship of the rest of the whole PDF, because I will be discussing the whole PDF tribology lecture page in total 44 page. I'll try to settle it within this series. Okay, so what are the link between this one and the rest is that at first we'll talk about the topology, meaning the surface roughness that I just said, or in a more detailed way. Alright, after knowing what is exactly the surface roughness and things like that, then we will talk about the different categorization. Alright, this categorization will talk about the surface contact, alright, friction, and wear. So these three types are often the problems or often the characteristics of a tribology systems. Okay, and then environment testing. So different environment will have different way of deteriorating the material because of wind. Alright, for example, you have this building over here, or maybe I should say the mountain. Or if you study geography last time, if the wind were to blow in this direction for the whole year, or you can start to see that this mountain will actually is being eroded. Alright, meaning the soil are being blown away. So the surface itself over here will start to get thinner and thinner, alright, as the wind blows. Alright, and this is why it's talking about the environment testing. So you need to know what the environments within there that will be included within this also. Okay, then we will talk about different multifunction tribo materials, where you try to create a material that is having a good surface. Alright, this will talk about the surface engineering process. So these are the last part of it. Alright, so as you can see, this introduction video tries to give you an overall perception or summary into the rest of the series that I'm going to talk about. Alright, so hopefully you kind of understand what I'm talking about. Yeah, so therefore in this video I shall discuss this thing in a way that is later on we will not talk about there, but in a way that it gives you a good perception of what exactly are all them. Alright, so therefore let's go into the slides. So this slides over here, take note of tribology. Alright, is that it's talking about the impact of friction, wear, and how you have a certain lubrications to protect it. Alright, and the rest is just for you to read through, because it's just something that talks about the focus to address. So mainly they're trying to address a certain issues within a certain stuff, the effect of a surface structure, alright, the texture, and the properties. Alright, the structures meaning I should say the structure of the building, for example. Or it can be this shape, it can be this shape, it can be this shape. Alright, so which type of shape, alright, will cause certain form of erosion, or perhaps because the wind is blowing over here, so in the end this part over here may actually erode in this manner. Or if the wind is blowing over here, maybe this part over here will erode. So different type of structures will have different form of this surface profile after a certain time. Alright, and therefore this is something that you can check it out, but I'll not discuss over here. So therefore yeah, I don't need to go through all this, but I just want to highlight this thing. So if I were to press this link, I can go towards something. Alright, I'll be given this thing, alright, and I'll just click this link and I'll go into this website from University of Delaware. And if I were to press this picture, it'll actually show us what exactly is tribology. Okay, and in tribology, what is the applications also? So it can actually goes into very like national security, energy and sustainability and healthcare. Okay, so you may feel this very boring, but I just want to highlight certain stuff that is trying to make you exposed to certain understanding. So in this type of wind turbine, alright, as you can see, the motor over here. I don't know whether I can see. This is the motor over here. So there will be a certain the piston is over here, so the surface over here may actually rub against the surface of the piston. Alright, and therefore you want a certain smooth surface. Alright, a modified low friction surface. Alright, if I were to zoom in, yeah, so it's more on the low surface type of thing. Low friction, sorry. So this is something that you apply for energy. Over in aerospace, the keyword, something that is not being discussed in the class, is this thing, self-lubricating solid lubricant materials. So it's often it lubricate itself after a certain time, I don't know, or the material itself oily or whatever, I don't know. You should go and check it out yourself if you want. But just to bring the exposure out to you that what are the things that is included into this system. As for biomedical, alright, if you take an arrow to the knee, then you can also put in something over here to protect your knee. Alright, and therefore a long time your knee will be rubbing against, your bone will be rubbing against the plate. Alright, the plate of I don't know what the hell, but anyway. So it also talks about certain self-lubricating system or self-lubricating material, so that it actually will not so-called rub away the surface of your bone, alright, a long time. So these are the things that you talk about. And lastly, there will be a certain solid lubricants, alright, that is trying to so-called protect the surface. So it's more on the low wearing, okay. So in this case, they actually have this composite, okay, it's nano composite. So the composite itself has certain dispersed particles. Alright, so these particles over here, if you were to look in the side view, is something like this. So if you rub against another thing, you actually cause this part over here to actually causes stress and rub away the surface. Alright, and it's not pretty good. So therefore, this solid lubricant somewhat helps you to reduce the stress. Initially, the stress was at this point, as we can see. But after you kind of apply your solid lubricants, I don't know what type of lubricants are they talking about, and eventually you see there is no any stresses at all. Alright, and therefore it's pretty cool. So the blue color one are the so-called the stresses, I would believe. Alright, while this everything over here is just pure cool lah. Okay, everything is chillax. So at least you get a feel of it. So just a warning, if you want to continue to listen, you can listen. Alright, because I don't know whether if you find it very boring. Okay, but if you want to listen, you can continue to listen. Alright, because in fact I haven't touched on anything about this yet. Okay, so or nonetheless you want to skip a bit. So I'll just keep on continuing talking about some things over here. Alright, because I feel that it's pretty important to actually note, or is I feel, or nobody feel. So over here, if you think about it, this is the amorphous, alright, and the black color lines, alright, I believe these pieces, I would believe, are crystalline, and maybe these pieces over here is amorphous. So amorphous are very randomly oriented, alright, I should say that is particles like that. Okay, while the crystalline are very neatly packed. Okay, so the different thing will cause different type of so-called friction performance. Okay, so these are the things that will affect your overall performance in terms of friction and wear. Okay, I don't know what is the magic behind this, but at least you get to know the different stuff. Alright, and in fact this picture explains everything about tribology, in the sense that in terms of the different way of how you look at it. So this is in fact the first way, and then the second way, alright, is the strength and toughness contiguous reinforcement. So let's take a look what is contiguous. It says sharing a common border, alright, sharing a common interface. Okay, so yeah, good question. So I would believe the contiguous is just, for example, this is your ship, okay, but you will have a certain reinforcement. This black color one, all this particular ships, these are all your reinforcement. Alright, but why is it contiguous? Because your reinforcement, alright, is at the same surface. Alright, if I were to look in, maybe I should look at this direction, the side view direction. Alright, there I can't see anything about the reinforcement. Alright, because the surface over here is very smooth. Alright, because they are aligning their border. Okay, so if I were to come here again, sharing a common border. Okay, so I believe they are sharing the same surface, just that this is the reinforcement. Alright, inside the material already, you can't see, but at the overall scale, is somewhat part of the body, but in fact it's not part of the body, something like that. Okay, but it helps to give you better toughness and better thermal transport. Okay, that means it's good in transporting, transferring heat. Okay, there'll be a certain disruption of transfer phlegm, so this part over here may actually, this is the particle, may actually so-called rub against the surface, I think. And take note of the micrometer, is very small, this one is in millimeter. Okay, so think about it. I will not elaborate because I also don't know what's the meaning behind why millimeter, why micrometer. Also, micrometer is more on microscope, then millimeter is more on, anyway, yeah. And then counterface surface, I don't need to explain. And then this is the large debris, so this will cause your wear and tear, I think. Alright, so don't try to go over this type of things, like you're gonna kill yourself. And yeah, I don't oriented running films. What is oriented? Align or position. So you kind of align it with your stuff. Okay, so I think this running films, alright, is this things. So these things are kind of oriented, meaning they're aligned. So as they are aligned, they are parallel each other, I think. That's what it's trying to say. So these films are that. And then over here, the link keep coming out. Let me. So fibrillation and toughness. Alright, it took quite a while to search for fibrillation. The meaning of that is talking about the fibers. Alright, the making of the fibers, for example. The forming of the fibers, it says. Alright, so what forms the fiber? Alright, because sometimes the wear and tear, you may actually tear the composite. Alright, so for example, you try to, this is a bread, alright, 面包, then you try to pull it apart. Alright, so when you pull it apart, alright, sometimes there will be this little stuff. Or you have to pull out a cheese bread or whatever. So there will be this type of things coming out. So this is called the fibrillation. Alright, and this fibrillation speaks about how tough, I think. I don't know, but let you think about it. But at least you can know the meaning of the fibers itself. Okay, light loadings of nanoparticles. Light loadings. I don't know why do you think it's light. I don't know why they want to load it light on the nanoparticle scale. Maybe because they want to make the surface a bit rough, so it's good for friction. I don't know what the hell, but yeah. Don't take my words as serious. I also know what I'm talking. And then over here, it's talking about the chemical compositions already. Okay, so take note of the keyword like chemical degradation, carbon conjugation. So if you're free, you can search it out yourself. Try to expand on this knowledge if you need. Alright, so take note of all this nanometer. You see, micrometer. This one nanometer also. So please take note of all these things. Alright. Nonetheless, it gives you a certain perception of things in a way that is, although it's very unclear, but at least you get a feel of it. Alright, and next thing over here, let's take a look on this link. I think it would be good if I were to go through the tribology. Okay, actually I should call it tribology after thinking about it. It's not tribology. But if I were to click this link, now I'm talking about tribology characterization, which is the first part. Okay, this dude over here. Okay, so the characterization, it's best if I were to use this video.
Meet the Nanovia Tribometer, the most highly advanced tribometer with the widest range of speeds for micro through macro, rotational and linear wear testing modes. With a single system, the tribological properties of liquids, hard coatings and substrate materials can be precisely tested in environmentally controlled conditions. Like most tribometers, our wear test is based on constant load versus depth measurement. During the wear tests, Nanovia's user-friendly software builds a detailed graph of load, depth and friction. But the Nanovia Tribometer is unlike any other in one all-important respect, because it has an almost endless range of measurement tools, more precise speed control of rotational and linear modes, more environmental variations, temperature control, liquid submersion or application, and multiple atmospheric variations. The Nanovia Tribometer is clearly the superior choice for the widest possible range, precise speed control of...
So if I were to explain on this, in case that you don't know what the hell is this, why did I click Arduino? Yeah. Anyway, so over here, this is the meter, okay, and your display, you put your specimen on here, okay, and then display over here will turn, okay, and you'll rub a certain surface, you'll create a certain so-called indentation, or well, not indentation, but rather you'll rub off the surface. So after rubbing off the surface, they'll kind of like read, or what type of surface roughness is this material is, and things like that. So this is how they carry out for a rotational one and also a linear one. As you can see, this part over here is the surface where you rub, okay. So these are the things that you should also take note of. So in your slide, they actually talk about the misalignment, okay. So over here, right, this is the transducer, alright, the one that is picking up the information, which is this one. Actually this grey color one. So this is called the transducer, okay. And therefore, this transducer will actually hit on, like, place on top of the surface, and then the sample, and then you go around and rub, okay. But however, if your this particular so-called, they call it counterface, I think, I don't know. So if you put your sample in a slanted way, or we call it the misalignment, alright, then you will cause a certain bias in the friction, okay. So this is why they run a test to let you know the different biasness in there, okay. And misalignments will cause this bias in the friction coefficient. And so in unidirectional, meaning one direction, so it's the forward direction. So if you were to go in the forward direction, alright, the bias cannot be determined, okay. So you don't know whether are you really in the bias or not, alright, the coefficient measurement. And therefore they will use a reversal method, alright, that goes in the reverse way, that then this bias can be easily identified, and then you can edit from it. Hopefully you're kind of clear, alright. So imagine you have this transducer, okay, standing in this manner, okay, and then it's placed onto your material surface, and you kind of rotate and turn. But however, if you didn't put your material properly, you slant it a little bit, alright. If in some way, I don't know how is it forward, how is it reverse, alright. But if you go in the reverse, if you go in the forward manner, okay, you can actually you can't actually see whether is it biased or not. But if you were to go in the reverse direction, alright, at least you get to know, because in unidirectional sliding, yeah, that's the word. So I believe this is the material, this is the side view, alright, and this is the transducer. So if you were to go in this direction, you're unable to see. Why? Because for example, if this is slant, you are going upwards, you can't actually feel it, I think. But if you were to go reverse, you can feel it, I don't know. Or maybe because if you were to go reverse, alright, it's rubbing against this surface, and you'll kind of like create a certain scrap over here, and you'll scrap off the surface at here. So it's easier to identify rather than that, I don't know, for you to think about it. At least you get to see the different type of thing that is coming out, okay. And this is in terms of measurement of friction and wear, okay. So when talking about like tribometer, alright, there's this word called tribometer, the one that I showed you just now in the video, alright. It's a measurement of the friction and the wear, alright, so be careful of that. And then after that, environmental testing, I no need to explain much, I guess. And I think I should go through because it's quite interesting, okay. So conventional thing, so you may think that friction and wear is the material property, okay, you may think so, but it's not, okay. So just now we used the tribology, right, we talk about friction and the wear, Tiobo. So therefore the friction and the wear aren't the material properties, but rather that is more dependent on the surface roughness of the material, the chemistry, composition, environmental compositions, pressure, temperature, velocity, and contact pressure, alright. Because if you were to press it, for example, this is the material, you place it onto another material. If you press it very very hard, alright, if you press it very very hard, and maybe this material should extend, and then you go in this direction, okay, this thing will go in this direction, alright, it will create a more indentation rather than if you press it softly and you move it, right. So these are the things that are pretty cool. And therefore this picture over here shows the temperature graph, alright, for epoxy and I don't know what the hell, another plastic I think. So the amount of friction coefficient drops as the temperature increase, because it's kind of melting already. Alright, so when it start to melt, alright, then it become like a liquid. So when it becomes a liquid, it's easier to actually so-called move around and lesser friction because it's more on water, more watery. Okay, so therefore you see it's kind of going downwards in this manner. I don't know whether it's become watery or what, but yeah, something of the meaning to give you. So this picture also very interesting. Okay, they're trying to simulate a certain environment. Okay, so this thing over here, I don't know whether you can see. Alright, this thing over here is the transducer, or the one you put onto the material. That's now I keep drawing, right? This thing, and then you put onto the material, and then you dun, like which one? Give me a while.
Because it has an almost endless range of measurement tools.
Yeah, that's what I'm talking about. Okay, so the particular thing that I've just drawn, alright, this one, is that is the particular thing that is rigid. Alright, when this thing over here will keep turning, alright, as the arrow will imply. Alright, as this, maybe I should copy this picture up. So this arrow actually is good. So you place your specimen on top here. Alright, this is your specimen, and then after that this rotating, this will rotate. Okay, so they call it a surface thermocouple, and then they'll have a certain nitrogen flow. I think you're trying to put in liquid nitrogen to give it a very cold temperature. Alright, so there will be also a nitrogen stream, or I don't know what the hell, but they're trying to make the material start more colder. So once it's more colder, then they are looking at if it's cold, then what is the so-called problem that is within that. Okay, so they are trying to simulate environment so that the specimen is cold, and then you can measure the friction again, things like that. So it's pretty cool also. Alright, then just a double check. Alright, we have done this. Alright, next we're gonna talk about the developing a multifunction tribal materials. Tribal materials. Okay, so I would still think that this part over here, probing buried surfaces, is still talking about the second one, environmental testing. Alright, still talking about testing stage, where in this testing stage they're talking about the different probing device. Alright, the transducer. Alright, so the different transducer will give you different measurements. Alright, and you see the thickness over here as compared to this one is more sharp. This one is more sharp, and then this one over here, I don't know what it's trying to do. And then over here, I think it's more on scratching, as it says it's trying to scratch. Okay, and I don't know what the hell are all these subscripts. I don't understand also. And micro tribometer. So think of there's a microscope, so you can actually measure the amount of surface being rubbed off of whatever. Okay, and then okay, so there'll be a micro tribometer. So in terms of micro, they have a probing. So they have this probe. So this probe is in terms of a micrometer. So if you were to hit onto micro surfaces, you can actually measure the amount of micro. So it's a very controlled surface. So for example, let's say this is the micro tribometer, for example. Okay, so this is the surface lah. Okay, so this surface, for example, if it's round, alright, this surface is full of micrometer type of surface roughness. So each of this thing over here, I believe, has certain probing so-called sensor or whatever. So they can actually measure in terms of micro level. Okay, and therefore it's called a micro tribometer. Alright, and it allows certain oxygen flow, gas inlet, exhaust. So I think they're trying to make an environment, alright, to simulate an environment, and so on and so forth. Vibration, so you want to have a vibration isolation table so that you will not cause natural frequencies, or because vibration itself will actually cause your whole system to be a bit unstable. Alright, and this will actually cause your specimen to move a bit or misalign, because this is your probing device, this is your material, and if your table over here is a bit slant, misaligned, then your whole material will be misaligned, and then your probing material will collect a misaligned data, which is not accurate. So the vibration table is very important also. And then over here, same thing. I think there are some tribal from trying to test the thing, I think, and then there are certain environmental systems to do things, optics, so they're trying to capture in terms of micrometer or whatever, I think, and it's pretty interesting also. So this is in terms of the probes. Alright, the probes, if you were to type probes, it's just a equipment to measure something. Okay, so the equipment to measure something is in terms of whether is it large scale, is it a nano scale, a micro scale, or is it a by cm, by meter, or whatever. So they're trying to actually measure surface roughness. Okay, hopefully this is pretty clear. I may be wrong along the way, but yeah, just at least you get a more good feel in there. So next one is the last one, which is the developing multifunction tribal materials. Okay, so so the first sentence, I don't know what he's talking. New high performance materials are needed before many new technologies will become tractable. Like, before many new technologies become tractable. So tractable means easy to control. So how does easy to control a technology will delay the performance of the material? Like, I don't know what is going on. Anyway, so tough polymer nanocomposite designed to produce low shear strength. Alright, transfer films can be thousands of times more wear resistance than the reinforced polymer. So these are the things they're talking about, the tribal film. So this is the one he's trying to say, the transfer film. Alright, so it's trying to protect the material. So these materials have been used to produce multifunctional blah blah blah. Alright, I don't know what the hell. But yeah, I think this tribal film is trying to protect the inner material. So there will be a solid lubricating nanocomposite. So I think this solid lubricating nano, the brown color one, are the things that is self-lubricating. Alright, trying to allow the system to be self-lubricating so that it can resist certain wear, I think. Alright, and then structurally and compositionally graded interface. Alright, so what is it about? I would recommend you can go to ResearchGate. Alright, if you type in composition grading meaning, and then you go to search for ResearchGate. Alright, this one. Alright, so if you click in, they talk about the different compositions variation with the depths. Alright, I don't know what is going on, but you can read yourself if you're free. A lot of equation, like seriously. So yeah, then after I type tribal material, it give me tribal material. Great. No, I'll let you think about it. But after thinking about the first sentence, I realized that if you have new technologies coming out, alright, this means that new technology coming out requires better material. Alright, and therefore we're going to talk about having a high performance material. So therefore, more materials, alright, you can actually provide a more alternative for better technology to come out. So the material is very important because it fulfills the technological demand, and this is what it's trying to say, I believe. Okay, and therefore this is one thing that you can do to actually improve your material, or in terms of the frictional wear and tear. Alright, so take note of the high strength and conductivity bulk. They are in terms of a micrometer. Alright, even though I don't know what the hell is going on, but the solid lubricant is trying to lubricate all the parts, I mean all the little stuff, because they're in terms of micro. And nonetheless, these are all the little stuff here and there I'm trying to touch on. That is because I never listened to the lesson properly. Good job. So all along, I think this is it. So yeah, and therefore this is this three stuff. Alright, in a way that is really, but it's good for myself to know at this moment, which is not bad also lah. So yeah, so see you in the next video to talk about topography. Yeah, see you.